Hello guys, welcome to Bugs in Code. The problem that I'm going to explain today is partition the array. But before that, if you are new here and a person who likes stuff related to coding, then you can subscribe the channel so that you get notified when I push a new video. Okay, so let's get started. Here is the problem statement and it says that you are given an array of n integers. Your task is to partition the array into four non-contiguous subarrays P, Q, R and S such that each element of the array A should be present in exactly one subarray. Okay. Let W, X, Y, Z be the sum of elements in PQRS, okay, respectively. Find the smallest absolute difference between maximum and the minimum among W, X, Y, Z. Okay, let me explain the problem statement. It says that you're given an array and in this array you are going to divide this array into four partitions, need not to be equal size. Okay, now let's call the partitions as P, Q, R and S. Okay, now in each partition, because as we have non-empty partition, so we are going to have some element in this partition. So let's say the sum of each element, the sum of elements in each partition is represented by W, X, Y and Z. Okay, and among these values, let's say max is representing the maximum sum. Okay, maximum of all these values. Okay, and min is representing the minimum of all these values. Okay, our task is simple, that we have to minimize the sum between minimize the difference between max and min. Okay, now I hope the problem statement is clear to you. This is what the problem says. Okay, so see, we have to find the smallest absolute difference between maximum and minimum among W, X, Y, Z. Okay, now an example is given here. Let me explain the example. The example says that we are given an array of size 5. Okay, now in this array, we have elements like 4, 2, 2, 5, 1. Okay, so we can, there are multiple ways to make the partition in this array. Like we can make partition like 4, 2, 2, 5 and 1. This is one of the partition. Or I can make a partition as 4, 2, 2, 5, 1. Okay, or I can make a partition as is there any other possibility? Let's say I can make a 4, 2, 2, 5 and 1. So there are multiple possibilities. Okay, but among those possibilities, one of the partition that I can see here is this one. See, this partition, as it is having a single element, so the sum is going to be 4 here. Okay, now for this partition, the sum is going to be 4 again. For this partition, the sum is going to be 5 and 1 for this. Okay, now what is the maximum value that we have? 5. But the minimum value that we have? 1. Okay, so these are representing W, X, Y, Z basically. And now we have the maximum and minimum value as 5 and 1. So 5 minus 1 is going to be 4. And 4 is going to be the output, because 4 is the minimum absolute difference that we can see among all the partition that we have. Okay, now I hope the problem statement is clear to you. Let's talk about the solution now. Okay, so okay, I'll start with the intuition first. Let me write intuition here. So I'll start with the intuition first. Okay, now let me come to this again. Okay, so this is the let me start with the intuition. So we are given an array and our task is simple, that we have to divide this array into four parts. Okay, and let's say W, X, Y and Z is the sum of elements for each partition. Okay, now we have to minimize the difference between maximum and minimum. Okay, how to do this? Let's say W, X, Y, Z are in sorted order. So I can write W, X, Y, Z. So this is the sorted order of W, X, Y, Z. Okay. Now one thing is simple, that this is going to be the max value and this is going to be the minimum value. Minimum value. Okay. Now maximum minus minimum is something that we have to minimize. Okay. And in order to minimize it, what observation I am going to tell you is, in order to have the minimum possible difference, we want all values are as closer as possible to each other. Like for example, let me give you an example. The example is, if I have one of the values as 1, 2, 5 and 19. These are the values of W, X, Y, Z. And one more possibility is 1, 2, 5 and 7. So you can see that these values are much closer to each other than these values. So this is the point from where the intuition comes. Like this is going to be the more optimal way of doing the partition instead of this way. Why? Because this is going to give me the maximum minus minimum as 18, but this is going to give me maximum minus minimum as 6, and so this is going to be the most optimal answer. So I can write my first observation that I can write my first observation. The observation is simple, that in order to get minimum absolute difference between maximum and minimum, I can what I can do is, okay, so in order to get the minimum absolute difference, I can like find the sum values. What are my sum values? W, X, Y, and Z as close as possible to each other, right? Okay, but the question is how to do this, so this is going to be my observation. I'm going to copy it. I'm going to copy this observation because this is really important. Okay, now this is about the intuition. Let's talk about the approach now. Okay, so first of all, I'm going to write my intuition here. So this is the intuition that we have. Let me write the intuition here. Okay, now I'm going to take the example. So I have an array as the example. The array have the elements like 4, 2, 2, 5, 1. Okay, now what are the possible partitions for this array? One of the possible partition is at this point. So I can write 4, 2, 2, 5, 1. So I have this element and I have this particular element partition. Okay, so I have two partitions here. Again, I can put partition at this point instead of this point. Okay, so the partition will be something like, for this I have 4, 2 and 2, 5, 1. Okay, one of the partition can be at this point, so it will be like 4, 2, 2, and I will have 5, 1. After that, one of the partition possible is I have 4, 2, 2, 5 and 1 here. Now I cannot have partition like empty and 4, 2, 2, 5, 1 because I don't want an empty partition. Okay, now since I have to write four partition, like these are the two partition of the array, you can see that I have two partition here for each possible partition. Okay, but I want four partition. So again, for this partition I can further make two partition for each left and right part. Like this is the left partition, this is the right partition. So again I can divide these into two parts. Okay, is this possible for this one? No, this is not possible because I have only one element here and I want at least two element because I want non-empty partition, non-empty, right? Okay, now for this uh there is possibility like for this I can make a partition like 4 and 2. Okay, and for this I can there are two partition possible, like I can make 2, 5 and 1, or I can make 1 and 2, 5. Okay, or I can make 2 and 5, 1. These are the possibilities. So for this time I'm not going to write them, but there are possibilities for this partition. Okay, now for this again I can make the partition because there are three elements and I want only two. Okay, two partition. And for this, on the right hand side you can see that I don't have any element. I have only one element and I want at least two element because I have to make two partition which are non-empty partition. Okay, so there is no possibility for this point as well. Okay, now you can see that I can make only partition from the point 1. Why? Because I want at least two elements. So when I start making partition from this point, so I will have partition as this one for this I. Okay, so I'll start from the 1. I'll start from 1 to which value? You can see that for this value, if I make partition for this value, then the partition will be something like I have this partition and this partition. So this is going to give me only one element on the right hand side. So I have to make I can't make this partition. I can't make this partition. Instead, I have to make partition at this point. This is the maximum value that we have. Okay, so this is n minus 1, this is n minus 2, and this is n minus 3. So I can make only partition till n minus 3. N minus 3. So okay, this gives me an idea that I can run a loop. I can run a loop. How to run a loop? Let me show you. Okay, so I can start a loop for I equals to 1, I smaller than n minus 2, and I plus plus. This is what I can write. Okay, inside this I can make further two partition which are going to be, I have left partition which is going to be partition from 0 to I. okay, and I can have a right partition because I want four partitions, so I can have a right partition which is going to start from I plus 1 to okay, n minus 1. This is the last point that we have. Okay, now for this, what this partition are going to give me, this is something very important. This is what I'm going to tell you, that I'm going to make a partition. Okay, now let's see for like this one, this particular case. Here I have three elements for the left partition. Okay, so I hope you guys have noted this down because I'm going to remove this now. So I'm going to consider a case now, and the case is simple, that I have 4 2 2. Okay, for this is my left part, this is my left part. Okay, for this there are two partitions possible. The first one is 4 and 2 2. Okay, and the second partition is 4 2 and 2, right? Okay, so what is the sum for element in this partition? 4, because I have, for this the sum is going to be 4 because I have two element, 2 and 2. 2 plus 2 is equal to 4. Okay, fine. Now for this the sum is going to be 6, and for this the sum is going to be 2 again. Okay, so I have these sum values. Now see, I have to consider only one partition among these, among multiple partitions. For this case there are two partitions possible, but even if I have multiple partition possible like 4 or 5, so I'm going to consider only one of them. Okay, so which one to consider among these two, this is the question. Okay, now I want you to see one thing here, that I have 4 as the maximum sum and 4 as the minimum sum. So what is the difference here? Difference is going to be 0. Okay, for this the maximum sum is 6 and the minimum sum is 2, so difference is going to be 4 here. Now I want you to notice one thing, that can I say that these values are much closer to each other than these two values? And this is what I want. If I talk about the intuition, so I said that I can find the sum values as close as possible to each other. Okay, so I want the sum values which are as close as each other. So you can see that these are much closer than these two values, so I can't consider these two values, because if I take these value, then in worst case I can have the maximum difference as 4, but these are going to give me 2, like 0. Okay, so I will consider this partition. But how to implement this? This is the theoretical thing. Can I implement this? Yes, of course I can implement this. Even let me write a simple pseudocode here to implement this. So I'm going to remove this. After that I'm going to make this smaller. So let me store this thing, here. Okay, so now here I'm going to write the pseudocode. How to do this? This is the question. Okay, so I can run a loop again. I can have a loop from let's say, okay, let's say this is the lower index that we have. This is the lower index and this is the higher index. See, when I make the partition, then I hope you have noticed that I'm passing two indices here, that from which point to which point I'm going to make partitions. So these lower and higher are going to represent those 2 points. Okay, so I'm going to make partition from low to high. So I'm going to use this concept like here. I can start a loop from low, and after that I can move to like R, and this is how I can make the partition. Okay, after that, when I'm at a current point of the partition, like you can see that let's say I'm at this point. Okay, so I can do something. I can calculate the sum of the left part and the right part. Okay, and how to calculate this? Just don't think about how to calculate this. For now, I just want to show you the concept what I'm going to use. Let's say I have the sum of left part and right part. Okay, so let me show you. Let me write this here as well. Here I'm going to write that left is going to represent the sum of left part. Okay, and right is going to represent the sum of right part. Right equal to sum of right part, right? Okay, after that I want the difference between the sum to be as minimum as possible. Why? Because this is going to give me the close values. Okay, so I will say that if like right minus left, because I know right sum is greater, so even let me take the absolute value. If I don't know which sum is greater, so absolute of right minus left is something which is smaller than the maximum value that we have. So I will have a max sum minus min sum, because this is what I have to minimize. Okay, so if this is true, in that case I will make my max sum as maximum of left and right, left and right, and I will make my min sum to be minimum of left and right, right, left and right. Okay, now at last I will have my maximum and min sum, so I am going to return a pair which will be representing my maximum. Okay, so let's not write pair, I am going to return a array. So this is going to store max sum and min sum, right? This is what I can do. Okay, now the question is how to initialize the maximum and min sum. So since I have to minimize this value, so initially I will store some maximum value, so I will have my max sum as any max value, okay, and min sum as 0, min sum as 0, because in that case only I will have the minimum value for I will have the maximum value for maximum minus minimum initially. Okay, so now I can do something like this, I can do something like this. Okay, now so I can have a function which is partition function which is going to perform this function. So even if I write here, so this is about the partition function, like I will have a partition function, uh, partition function. This is what I have, so it will have a low and high index. Okay, now let's talk about how to calculate the left and right sum. This is the question that we still have not done yet. Okay, so this is the question that how I'm computing the sum of left and right part. Okay, now let's talk about this, but before that here I will have the left sum and right sum as menu. So I can see that I can see that here the left and right are the some values which are written by this partition function. So this is an array. Okay, and first element is maximum, second element is min sum. Okay, so I can have an answer that I have to minimize. Okay, so it is going to give me minimum of answer that I already have and a value. But what is the value? Let me calculate the value. Value is going to be maximum of, okay, so value is going to be maximum of left of 0, because this is the maximum of 0. You can see here that this is the maximum of 0. Okay, after that I can have right of 0. Okay, I will even explain what I'm doing here. So I will have a left of 1 and a right of 1. Okay, let me explain this. If I have partitions like you can see that if I have this array and I have made some partition inside this array, so for this left part I have one max sum and I have one min sum. Okay, so these are the these sum value are coming from the partition that I have made here. Okay, again I have for this one as well max sum and min sum. Okay, now the maximum of all these value, because these are nothing but w, x, y and z. Do you agree? Okay, so maximum of this value is going to be maximum of these two values. That's what I'm doing here. And minimum is going to be minimum of these two values. So that's how I'm performing maximum minus minimum. And after that, I'm just minimizing this value. You can see that at this point. Okay, now the idea is simple, that I have to return this value. So my task is to return answer. Now I hope the idea is clear to you. This is about the naive approach. So even don't worry about the optimal approach, because the naive approach is something which is 90% of the optimal approach. So you can see that this is the naive approach that we have. What is the complexity of this approach? The complexity of this approach is going to be O of n square. Now still we have one question, that how to calculate the sum of this left and right part. Okay, now let me explain you. So in order to calculate the sum of left and right part, let's say we have an array 1, 2, 3, 4, 5, and I want to ask from you that how to calculate the sum from this like the sum of this range, or the sum of this range, or the sum of this range. How to calculate? So you will say that okay, I can start a loop from this point to this point and then I can calculate the sum, but this is not the optimal way of doing this. Instead, what I can do is I can have a prefix array. So I will have a prefix array which is going to give me the sum of these elements. Okay, let me make a prefix array. So a prefix array will have the sum values as 1 for this, after that 1 plus 2 3, after that 1 plus 2 plus 3 which is going to give me 6, after that I have 6 plus 4 which is 10, after that I have 15 here. Now if I ask you that hey, can you please give me the sum of from this range which is 0 1 2 third index and the first index, so can you give me the sum? Yes, of course we can give you. We can give you using this prefix sum array. prefix sum array. How to give the sum using prefix sum array? I will have a 4 index which is at this point, and I will have the second index, first index which is at this point. So if I do something like 10 minus 3, okay, so if I do something like let's say this is index I and this is the index L, and I want the sum at this particular point, so I can do prefix of I minus prefix of L minus 1. So because in order to get the sum of this particular area, what I can do is I can calculate the sum of this whole part first, and after that I can subtract this part, which is the left part of this part. So in this way I will get the sum of this part. Okay, so that's what I'm doing here. Prefix of I is going to give me the sum of whole part. After that I want to like subtract this particular part, which is one index left of the left index that I have. So this is what I'm doing here. Okay, so this is going to give me the sum of any range. Okay, when I'm doing partition at this point, when I'm doing partition is at this point, so I need one prefix array. One thing is sure that I need one prefix sum array. Okay, now the question is how to calculate the sum. So if I'm at this point, like I have an array like 1 2 3 4 5 here. Okay, and I'm at this particular index I, so the left sum here is going to be, and the lower index is L and the higher index is here H, right? Okay, so I can calculate the prefix the sum of left area, which is this particular area, by doing simply I minus prefix sum of I minus prefix sum of L minus 1. Let me write this here. So I can do something like, okay, so okay, I can write here prefix sum of I minus prefix sum of L minus 1. Okay, now what about the right part? For the right part I am first going to write, after that I will show you why I have written this. Okay, so I will write prefix sum of high minus prefix sum of I. How I'm writing this? Because see, in this case, if I'm at this particular index I, so I want the sum of this range. So how I can calculate? I can find the sum of this whole range. After that I can write, I can subtract the sum of this range. So this is prefix sum of I, which I want to subtract, and this is prefix sum of H. So this is what I have done here. Now I hope the idea is clear to you. So this is all about the first approach that we have, which is an O of n square approach. Let me show you the code for this. So here I have the code. On the left hand side I have the Java code, and on the right hand side I have the C++ code. Now you can see that the first thing that I'm doing here is, you can see that the I'm starting a loop from I to n minus 2, as I have explained you. Okay, after that I'm having a function which is max min function, which is same as the partition function that I have explained you here, same as this particular partition function. Okay, now this max min function is going to give me two values, which is the maximum value and the minimum value. After that I'm finding the value which is max like maximum of the right and left. Okay, after that minimum value is going to be the minimum of right and left minimum. Okay, and after that I'm just minimizing this value and storing in a variable answer. Okay, now what about this linear function code? So this is the code that we have, and I'm calling it a linear search. Why I'm calling it linear search? Because it is searching linearly for a value, for two values which are very closer to each other, like left and right sum, and we have to search for two values in such a way that those values are closer to each other. So this is what this function is going to do for us. Okay, now I hope the linear search is clear to you. This is about the C++ code that we have. You can see the C++ code as well, and I have written the Python code as well. So this is the Python code that we have. Now I hope the idea behind linear search is clear to you. So let's talk about the optimal approach now, because this is not going to be accepted. This is having the time complexity of O of n square, but the required time complexity is O of n log n. Okay, so log n that we have. Okay, now let's talk about the optimal approach. Okay, so I want you to notice one thing here, that we are performing linear search. And if I talk about the prefix sum array, see let me tell you one thing, that we have the prefix sum array. and the prefix, let's say for array is 1 2 3 4 5, the prefix sum array is going to be 1, after that 3, after that 6, 10 and 15. So you can say that this prefix sum array is going to be in sorted order. Okay, now if this prefix sum array is in sorted order, so we can apply, we can use binary search here. Binary search here. See, our task is simple, that we have to find two values, which is my max sum and min sum, which are closer to each other. This is what my goal is. Okay, so how I can find this value? How I can find this value? I can make partition at any place. Let's say currently my partition is at this particular position I. Okay, now when I make partition at this position I, so I find that the sum on the left hand side is 10 and sum on the right hand side is 15. Okay, so now I can see that the left sum here is smaller than the right sum. Okay, so in order to make these values closer, I can increase this value. Do you agree? I can increase this value, because if I decrease this value, in that way I'm going to have more difference between these two values, so these will not be closer to each other. So instead of checking for these particular values, I can directly jump to the value ahead of these values. So now you can see that I'm avoiding comparing these values. This is what gives us the idea behind the binary search. So our task is simple, that my task is simple. Let me write the task. The task says that if absolute value, the condition will remain same, that we have to check, like right sum minus left sum is smaller than, okay, let me write right sum minus left sum is smaller than max sum minus min sum. In that case I can change the value, like my right sum, okay, my max sum is going to be max of, my max sum is going to be max of right and left. Okay, and my min sum is going to be min of right and left. Okay, now the question is, if my right sum is smaller than left sum, as I have already explained you, that if my right sum, okay, if left sum is smaller than right sum, what to do in that case? In that case, like let's say for this, let's say, okay, so let me erase the extra stuff that we have here. Okay, so we have this array, right? And in this array, let's say I'm at this index, and I know the difference is going to be the sum values that we have is 10 and 25. Okay, so now the question is, see, we have this value which is smaller, so I can increase this value. So instead of checking this value, if my low is here and high is here, this is my low, this is my high, I can directly make my low equal to this particular value. Why? Because I'm not going to make partition at this point. I can simply avoid this point, because these points are going to give me smaller value for this sum, and I want this value to be greater, because this value should be as close as possible. Okay, I hope the idea is clear to you. So in that case, I'm simply going to make my low as, my low will be mid plus 1, and in else case my high will become mid minus 1. I hope the idea is clear to you. So this is what gives us an idea behind the binary search. Now this is the code will remain same. We are just going to replace this linear search with the binary search. Let me show you the code. So binary search code will look something like this. There is no change in this part, but there is change in this part. You can see that we have changed the function here, and now we are performing the binary search. We have the lower index and the higher index, and now we are okay. So again, the same method is going to be used for calculating the like left sum and right sum using the prefix sum array, and after that we are going to check the same condition that we have in the this function as well. Okay, now this is something that is going to perform binary search. Like each time we are dividing our search space into like half. Okay, now you can see that these conditions are same as that I have already explained you. Okay, now let me show you the C++ code. So this is the C++ code, and this is the function that we have, which is going to perform the binary search. Okay, but something that I'm interested in is talking about this particular code, which is the Python code. In Python code, when I wrote this particular approach, then it was showing me time limit exceed. Okay, so I have modified the approach a little bit. So like of course the concept is going to remain same, but we have a little change here, that instead of finding two sum values, I'm finding one like I'm finding those two values which are going to give me like close value of okay, so let me explain this. Let me explain this here. So if I have like, if I have an array 1 2 3 4 5, and I have 5 plus 4 plus 3 plus 2 plus 1 15 as the sum. Okay, now I will find a sum value which is very closer to 15 by 2. So this is like dividing the sum, dividing the array in such a way that the sum gets divided by 2. Okay, so I will find a value which is as close as 7. So this is the same concept that I'm going to use, because the rest sum will going to be equal to like will be as close as possible to 7. Okay, so like you can see that here for this 1 2 3 4 5, if I make partition at this point, so I will have 7 sum. Okay, so let me check this 3 plus 2. Okay, so I will have 6 sum here. Okay, and this is going to give me 9. So this is the uh, optimal value that we have, that we can find using the binary search. So this is what I'm doing here. Now I hope the idea is clear to you for the Python code as well. So this is all about this problem. I hope the problem is clear to you and the approaches are also clear to you. Thank you.